Okay, everyone, I'm going to very quickly give you an overview of each of Newton's three laws and kind of go over how free body diagrams work and what static and dynamic equilibrium mean. So in 4.4, you should have read a little bit about Newton's first law, which describes inertia. And this is a commonly misunderstood law. Okay, so Newton's first law says that an object at rest will remain at rest. Object in motion will remain in motion at a constant speed in a straight line, unless there is an unbalanced force, and that is the most important part of the law. So unbalanced force, what does that mean? Well, this kind of is going to start the talk of equilibrium. So this concept of inertia really describes what we're going to spend more time on: static equilibrium, which means something is stationary, it's not moving, and dynamic equilibrium, which means it's moving in a straight line at a constant speed. Okay. So if there is an unbalanced force, okay, in 4.4 it says that forces cause acceleration. So this is also a law you've probably heard of, but it is sometimes taught incorrectly or misunderstood. Okay, so the most important part here is the net. So if there is a net force, then the mass of the object times the acceleration of the object equals the total force. Okay, so if there's no net force, there is no acceleration. Well, if there's no acceleration, that means we are either at rest or constant velocity, which implies a straight line. But I will write it to reemphasize. Okay, the third law isn't vital for tomorrow, really, but it's basically the action-reaction law. This will become a lot more clear to see later on in the chapter. And so for every action there is an equal and opposite reaction. So sometimes this can be explained very well with things like putting vinegar in a vinegar and carbon dioxide, vinegar and baking soda in a 2-liter bottle, mixing it with water, you form carbon dioxide. And when there's enough gas in the bottle, then the cap of the bottle will shoot off in one direction, and then essentially there will be recoil for the bottle. The bottle will move back this way. Okay, so the two forces that are acting on both the cap and the bottle itself, they're equal in magnitude, but opposite in direction. Okay, so that's the quickest way to explain the three laws, and of course we will be talking about these all chapter. we will be spending the majority of the time talking about Newton's second law. Okay, so now we will talk about free body diagrams, and this is actually very easy, especially at first. This is really like in the first unit when we looked at motion diagrams, which includes a full picture, to then the particle diagrams. This is kind of the same thing. So I thought you guys did very well of identifying forces on the physics classroom concept builder. So if you recognize the force, what you need to do is always do what's called a free body diagram. And so instead of taking the time to draw a person hanging from a rope, and you'll see this in the beginning of your book, in those first 4 sections, they will draw like sketches and then draw the force. We're basically just going to simplify it a little bit more and do what's called a free body diagram. Okay, so what you're going to do is you're going to put a dot in the center, and the dot is going to represent the center of mass of that object. Okay, so basically center of mass is not something we talked about yet, so basically right now it's just the object. So if this person is hanging from a rope, okay, so the person is not moving up or down at a constant speed or anything, they're at rest here, or stationary. So what that tells me is the forces must be balanced. So if they're at rest, forces are balanced. Okay, so the force that is always present is going to be our weight force. And please call it weight, or you can say mg, but don't say g. Okay, I'll circle that because g is acceleration. So don't write g either way. Write weight or mg. Okay, I'm going to write w for weight, or you can do a capital F subscript g. Okay, so basically 3 different ways to write that. And the force that's preventing the person from falling to the ground is the tension force in the rope. So you can write this with capital T, which is usually what I will do, or you can do an F T like that. Okay, and try to draw your vector arrows above. Okay, so there's no net force here. No net force. Okay, so the example that I just did is an example of static equilibrium. And this is mostly going to be what you're going to observe tomorrow. And basically what that means is something has balanced forces. So no net force. Okay, and this word static means like preventing motion. Okay, that's pretty much what that word static means. So the object is not moving, so the object is at rest. And tomorrow we're not going to do any math, but whenever we start to do math, any form of equilibrium is the easiest possible scenario. So these you're going to really want. So yeah, just read everything carefully and observe carefully if something is at rest, meaning it is stationary, there is no acceleration because there's no F net. Then we have static equilibrium. Alright, so here's our second example. So I just chose this. Amanda is pushing a box on the floor at a constant speed. Okay, so let's identify the forces here. There's a lot compared to the other example. So we know we have weight. We always have weight, and this is on the box. Because the box is what's going at a constant speed. Okay, I'm not asking about the forces on Amanda. So we know there's weight, and it is on the floor. So there's a force from the floor on the box that is pushing it up. So there is the normal force, which this is a flat floor, so it's going to be directly upwards. Okay, so maybe that's going to be down, this is going to be up. Okay, Amanda is pushing it with her hands. So we have the applied force. Oh my God. Okay, and I didn't indicate the direction. So usually you will assume the positive direction if nothing's given. But I'll just add to the right. So this force will be to the right. And you need to stop and think about this. If these were the only three forces on the box would be accelerating. It would not be at a constant speed. Because what we will see is that the weight force and the normal force will balance each other out in this situation. But we have, so that's in the vertical direction. But in the horizontal direction, right now we are only talking about the applied force, which is in the right direction. So in order for there to be a no net force, we need a force in the left hand side. And that is going to be one of our favorite forces, which is friction. And we will talk more about friction later on. But right now we're just going to call it friction. We won't even talk about the types of friction later on. But I'm pretty sure most of you are familiar with the concept of friction. Okay, so that must be to the left. Okay, so our free body diagram. Here's our box. So we have normal force, which you can use with a capital N or Fn or F norm, something like that. Okay, so the magnitude of these are the same. And then on my x-axis, we have my applied to the right, and balancing out the applied force is friction, which you can do FF. Okay. So what this is, so there is no net force in the X or Y, and in the Y it also is equal to 0. Okay, so what this is called dynamic equilibrium. And this is also very easy to understand. This word dynamic, this implies motion. Okay, and equilibrium means equal. This implies the forces are equal. So the forces are equal in both directions. Okay, so what this means is we have constant velocity. Okay, and so since we're still new, just to remind you, that means constant speed in a straight line. And just as a reminder, that means there's no acceleration. Okay, so I think this is enough to get us through tomorrow. So tomorrow, this will not be new to everyone. I'm going to give you, I think I have 7 different scenarios. And we are going to practice doing free body diagrams. Because this is an important skill. Okay, the reason why a lot of people could do poorly on a forces test is because they get lazy and they try to skip this step. And this step will be used the entire year. So please take it seriously and don't get lazy about it. Okay, I'm feeling a little bit better and I should be there tomorrow. Thank you. Bye-bye.